One of the most important aspects of data analysis is having a clear understanding of the distribution of your data. This is a fairly fundamental and simple step of any data analytics process. And perhaps because it's so fundamental and so simple, many data analysts and many marketers overlook this step, and they overlook its critical nature. When we talk about data distribution, we're referring to how the data points are spread out, how the distribution of data is shaped, and how various measures of central tendency are distributed within the range of the data. All this helps us to know which measures or numbers or summaries we can use to represent the data set when we want to communicate its nature to others within our organization or even outside of our organization. It also helps when we want to use that data set to make our own marketing decisions. Now, let's talk a bit about what I mean when I say data distribution. Let's say that our company has a customer service survey that it does every month or every week to assess, of course, how we're doing in the area of customer service. And that survey ranges, the survey scores can range from 0 to 100. If we use a number line to represent the possible responses, that we could then use boxes or dots or circles or a number of other visual representations to illustrate how many customers gave us particular scores. So let me do that by showing you on the whiteboard. Let's start by drawing a number line. We can just go from 0 to 100. And we could have in there, 25, 50, 75, whatever it takes, and along those lines. Now, if we were going to represent, let's say by circles, the number of responses we had at any particular score, then let's say we have a couple people who gave us a 50, and maybe some who gave us maybe a 60 and a 75, maybe a 55. Now, in this particular case, our data distribution is fairly evenly spread. And if we were to look for a mean within all this, the mean would probably be somewhere right there in the center, and it looks like that might be 62.5, and that would give us some idea about our data set. But let's say we go ahead and we add in some more numbers in here as well. And so let's say we had some people that ranked us up here, and we got a couple that were close to 100, and then we also had some down at the other end. And let me do this. Let me add in some more just so I can make it look a little bit bigger here in the top. And let's say for whatever reason we had a lot of people right there in the middle, and that might have been around the 55 range, and that's going to give us some type of an idea of our data distribution. Now, in this particular case, it looks like what we have here is what we would call a fairly normal distribution. Now, this idea of a normal distribution is just one that kind of goes up in the middle and back down at the other end. Some people call it a bell curve. And the great thing about a normal distribution is that its measures of central tendency are all pretty closely compacted together. So those measures of central tendency might be the mean. Let's say in this case, we're going to say the mean is at 55. And then the mode, which means, then the mean, of course, is just the average. The mode, meaning this is the number of, or the response that got the most number of, the number on the score that got the most number of responses. And so in this case, it looks like it might be that 55 again. And then finally, let's look at the median. And the median is the place in your data set where half of the scores are below and half of the scores are above. And in this case, it looks again like we're right there at 55. So it's important for us to understand how the data are distributed, because we're at some point going to use some number. Most likely we'll use either a mean. People will talk about, well, our average satisfaction score was 55, or hopefully it's a lot higher than that. Or they might talk about the median. We might hear people talk about median home prices or median salaries. And I'll tell you why they use the median instead of a mean in just a minute. Or also they might talk about the mode. Now, usually people won't talk about the mode necessarily, but the mode is important to us because it gives us some type of an idea of typicality. In other words, even if the mean or the median were over here, if for some reason we had a lot of people down here giving us 20s, and a lot of those people were out there in the world, then it seems like if you were to ever meet a person who gave us any score, it's more likely at some point that you'd meet a person that gave us a 20 rather than a person who gave us a 55, even though 55 is probably closer to the middle of all of these data points. So let's go ahead and let me show you another option here. And that is, what if we were to erase a big chunk of these on the end and have a data set that was more tightly grouped together? And so let's say that this data set kind of came up like this, it jumped up, and it went right back down. Now, in this particular case, I might still have the same mean, median, and mode, but because they're more tightly grouped, we can feel better about the idea that the mean, median, or mode is more representative of the data. In fact, if I were to erase even a few more of these and change my curve there, and if I only had maybe a couple here and a couple here, and I had them like this, then at that point I would have a data distribution that would look something like this. And then I would feel very comfortable with the idea that our satisfaction score is a 55, or in the mean, median, or mode would all illustrate this. Now you can see the problem with this if we were to do exactly the opposite. If I were to really spread these out and say that we had people that, and I'll just use kind of boxes here to illustrate, but if we have a lot of people that gave us different scores, and even if that median and median mode were still around the range of 55 or so, then in this particular case, because it's fairly flat across here, then that number really is not representative of anything. In fact, it could even be worse. What if for some reason we had people up here that there were more people giving us high scores in the near the 100 range, and a lot of people giving us high scores, or at least a lot of people giving us these lower scores down here in the 25 range? We would have what's called a bimodal distribution. But in that case, we'd have two modes. We could kind of wipe that one out because we'd have a mode here and a mode here. But the mean and median would still be right there in the center. And the center is not really representing a large group of our people. In fact, if for some reason I were to kind of erase those people and then bring this down and then back up again like this, then that center, that mean and that median, don't represent any of our customers. And that's important to us because a lot of times the data that we get from our data analysts, or the data we get from the people that are providing us with data, are going to be means, or they're going to be medians. They'll be averages. What's the average satisfaction score? Well, in this case, the average satisfaction score doesn't tell us anything because there's two groups. One group that's extremely satisfied and one group who's not satisfied at all. Now, let's take another look at other ways that we might have a data set distributed. Instead of being something that's fairly equal on both sides and being symmetrical, it may be asymmetrical. And of course, symmetrical could be a normal distribution. Symmetrical could be something that's perhaps bimodal or even trimodal if there were three modes in there. Or we might actually have things that are asymmetrical, where for some reason there's a little bit of people responding, a small number of people responding at the bottom end, but then many perhaps at the high end. And so this is going to skew our mean to the left. So imagine here, if this was my mean, right there in the center, but I were to start adding other observations down here at the other end. The more I add these lower observations, those that are closer to the zero end, the more I'm going to pull that mean over to my left. And as I pull that mean to the left, that means that the mean, perhaps, if this is the new mean right here, perhaps that new mean is no longer as representative of the bulk of my data set as it was before. In fact, I might even have something happen where, let's say in this particular case, I have several people that were down here at the zero range for some reason, and that really pulls my mean this direction. As that happens, my mean may end up, somewhere around here, and it's really not representative of the bulk of my data. in the bulk of my responses that I have. And of course, this is skewed to the left. We could have equally something that was skewed to the right. Which, by the way, this is the reason why people use medians for home prices and for salaries. And that's because if you were to constrain home prices at 0, and then of course there's no constraint on how much you can pay for a house, and the same thing would happen with the salary. You wouldn't have people making less than a 0. In fact, in this case, they're probably making, here's the 0, and they're making something more than that. What happens is that the mean is pulled so far to the right that it's just not representative anymore. So we have $1 million houses or multi-million-dollar people, people even paid multi-millions of dollars for some type of job, and it pulls that mean up high, and it's no longer representative of the data. And so what happens is people tend to use the median home price, where half of the people are here and then half of them are on the other side as well. And that median is less likely to be affected. In fact, for every, it barely moves when you have a new observation really high up, but that mean is influenced quite a bit by that observation, or quite a bit by what we might consider to be some outliers. So now let's look at something else that will help us to understand different ways in how we can represent the data. So one of the things we might look at is a box plot. Now what a box plot does is if we took the median, and let's say we draw this right here as the median. The median again being that half our responses are higher and half of our responses are lower. And then we were to take that and let's talk about quartiles. Now a lot of times the idea of a quartile is just that it's a quarter of your data. And so the median actually is quartile 2. And then if we were to go back to quartile 1, that's just the quartile that's before that. And so we can kind of just draw another line out to the side. In fact, this is also called a box and whiskers plot, these being the whiskers. And there's our Q3 and our Q4. And there's actually a number down here at the bottom, which is called Q0. And even though there is no quartile there, they're just using that to represent that particular space. So the Q0, or the quartile 0, is the same as the minimum, whereas the quartile 4 is the same as the maximum. And then, of course, the quartile 2 in the middle is the median. And so I'm just going to write this up here. So with these quartiles, now I have a picture of what my data looks like. So between quartile 0 and then, of course, this quartile 1, in that group, 25% of my responses are in that group. And then there's 25% that are in this group right here, between Q1 and Q2. And then quartile 3 has another 25%. And then quartile 4, of course, another 25%. So when these are fairly spread out, what that's telling me is that my data is fairly spread out as well. So let's look at an example where they're not spread out. So now let's take a look at another distribution. We'll go from 0 to 100. And we'll put our 50 here in the middle. And let's say that our median was here in the middle. So this would be our Q2, our median. But let's say that our Q3 was pretty close. And so in this case, our box for our box plot would be fairly compacted. But then there were still some scores out here in the 90s and went way out there, maybe even close to 100. And there's our Q4. And then on the other side, let's say that the Q1 was actually pretty far spread out. And then the Q0 is also all the way down here at 0. So with my Q1, I would draw another part of my box, and then the little whisker part for the Q0. Now, what this tells me then is that I've got pretty much that first quartile, that first 25% of the people are fairly spread out. The next 25% seem to be spread out even perhaps a little bit more. And then there's a group here that's a little bit tighter together. This 25% is tighter together, and then the other one, 25% of the people responding are spread out. What that would tell me is if I were drawing some type of a representation of this data, I might assume then, because these are so pushed together, that my curve would go up a lot higher here, and then it might drop off again here to get to the end. And so in this particular case, because there's more on the left of the median than to the right of the median as far as the spread of data, more spread, the same number of responses. If we surveyed 100 people, there would be 25% of them here. 25 people had given the scores here, 25 here, 25 here, and 25 there. But because these are spread out more, that spread, that push to the end, is going to pull my mean this direction. Let me give you an example that's more extreme. In the extreme example, let's go ahead and we'll put our median over here, maybe around the 60 range. And then we'll have a fairly tight group of people here from, say, 60 to 65. And then we'll have a group over here that's a little bit further out. And then we'll have this long tail to the end. And maybe on this other side, we'll even have a fairly short tail, maybe something that goes up to 70 or 75. Now again, I'll label them. Here's my Q0, my Q1, my Q2, my Q3, my Q4. Now Q2 again is my median. Q4 is my max. Move these numbers out of the way a little bit. Give us more space here. And then finally down here at the bottom, where the 0 is, this would be my minimum. What this tells me is that this half of my data, remember, there's 25% are between Q0 and Q1, 25% between Q1 and Q2, 25% between Q2 and 3, and 25% between 3 and 4. This top half is fairly compacted together. They're all together there. And so even though this is the median right here, these numbers over here on this other end are going to draw that mean or pull that mean in this direction. So what will happen is my mean will move this direction. Who knows where it will be? We'd have to look at the distribution within these quartiles. But we know at the very least that because of this type of distribution, the mean is going to be pulled to the left. If I were to draw this out in a curve, then most likely I would have something that looked like this. It was fairly stable perhaps, maybe a little bit more compact here, it's rising up, and then we're going to have this huge jump up here to the top, and then for whatever reason either it would peak out up here or it might have a quick drop to the end. And so we would have kind of a classic type of a left skewed or negatively skewed type of a distribution. This helps us understand that the mean, because the mean's pulled away from the other measure of central tendency, the median, that the mean may not be representative of our data. And it's important for us to understand it. And finally, let's look at one more. What I'll show you now is we'll draw out this normal distribution. And if we were to think about this and try to go from the normal distribution to the box plot, then what we would do is we'd say, well, we know there's a lot of people kind of in these two quartiles here. So if I drew my quartiles, I could say that there's a lot of people here, there's some out there, there's a lot here, and then there's some out here. So if I were to draw my box plot, I could almost do it just like this and say, here's my box plot, there's my median, there's my two quartiles in the middle. Those are my center quartiles, and that's why they draw them in the box rather than with the tails. And then the tail out to the end, and the tail out to the other end. And at that point then, all I have to do is erase my curve, and now I have kind of my typical box plot. And so with my Q0 at the end, my Q1, my Q2, the median, Q3, and then Q4 max. So it's not uncommon for us to see something like this or see it with the boxes shifted a little bit to one side or to the other. the key is that the reason why they put them in boxes here is that this is kind of the big group of your data that you're going to focus on. So let me show you a different one then, if we were to kind of change this up a little bit. Where I will take my boxes and make them rather large. And I'll have to move that Q3 and Q1. So in this particular case, what we can see is that this first 25% of the people are pretty tightly compacted. The next 25% are spread out. The third 25% are spread out. And then the fourth 25% are compacted as well. So regardless of whether my data goes from 0 to 100, we can even say that 100 is beyond this somewhere to the end. The key here is to kind of think that because these groups are closer together, then if I were to draw my curve would go up higher, and then it would come down lower here and perhaps in the middle areas, and then it would get up higher again. And so this would be indicative of some type of a bimodal distribution, because we have things here on the side and over on the other side. It's not to say that you can always look at your box plot and then be able to write out what your distribution is going to look like, especially considering the idea that within a particular quartile, you don't know what that distribution is. So to some degree, it's just a matter of giving us one more piece of information about our data. The best data always, of course, is to visualize it, to plot it out. And when you do that, then it's much better to be able to actually look at what happens within a particular quartile. So it could have been that in this quartile, we might have had another little lump up in there as well. Or maybe we had no type of lump here. Or maybe we had another one that was even right here close to the median, and it went up and then back down again. We don't know, because we don't know what's inside of there yet. But at the very least, this type of data visualization of giving us a box plot, the box plot at least helps us to understand a little bit more what our data is like. And especially when we start to compare one box plot to another box plot when we're looking at data sets, perhaps we have one segment, segment A and segment B, and then we say, well, let's take a look at the box plot, and the box plot gives us one other perspective on how to look at that data. And that's really the key here, is to use whatever tools we can, whether they're the numbers like the mean, median, or mode, or they're numbers like the 5-number summary, looking at the different quartiles, or maybe it's even things like looking at kurtosis or skewness, and you don't have to worry about those right now, but looking at how those numbers compare to other data sets or to other segments, market segments, and it gives you a little bit more information. The numbers are good. Illustrations like the box plot are better, and even better is when we can actually graph out the data and to see it in a frequency distribution chart.